CV4U1, Chapter 5, Session 12. In this session, we are working on questions from exercise 5.5 from the textbook. The first question is determining dy dx for each function. Y equals tan squared of x3, part C. Y can be written as tan of x3 to the power of 2, and its derivative is 2 times derivative of tan of x3 times derivative of inside bracket, derivative of tan of x3, which is 3x2 secant squared of x to the power of 3. Part F, y equals 3 sine of 5x tan of 5x. Its product rule, derivative of sine of 5x is 5 cosine of 5x, y prime or dy dx is 5 cosine of 5x times tan of 5x, plus derivative of tan of 5x, 5 secant squared of 5x times sine of 5x. We kept the constant outside of the bracket from very beginning. Question number 6, determine the local maximum point on the curve y equals 2x minus tan of x, where x is between negative pi over 2 and pi over 2. We are using first derivative test to find local maximum. The derivative of y equals 2x minus tan of x is 2 minus secant squared of x. If we set it to 0, x would be either plus or minus, a secant of x would be either plus or minus root 2. That means x is pi over 4 or negative pi over 4. We'll see between negative pi over 4 and pi over 4, derivative is positive. Between pi over 4 and pi over 2, and between negative pi over 4, negative pi over 2 and negative pi over 4, it is negative. Notice the function is odd. Therefore, the local maximum of the function is pi over 2 minus 1 when x is pi over 4. Last question. Determine the equation of the tangent line to the graph of y equals 2 tan of x at x equals pi over 4. When x is pi over 4, y is 2. 2 tan of pi over 4 is 2. Tan of pi over 4 is 1. Derivative of the function is 2 secant squared of x. When x is pi over 4, derivative is 2 times root 2 to the power of 2, which is 4. Therefore, the equation of the tangent line to the graph of the function at pi over 4 and 2 is y minus 2 equals 4 times x minus pi over 4. This can be written as 4x minus pi plus 2. Thanks for watching.